All right, so these are a few last questions. Describe the end behavior of the function. Again, please make sure that you graph it. But even without graph, this is a 7th degree, so that's an odd function. It means that in some way the ends are going to end up going in an opposite direction, one way or the other. But I would like to graph it at first. But even without graphing this function, you're going to be able to say this is odd, right? But let's look at Desmos. All right, so here is our function. I have graphed it. I literally just typed it in exactly the way it is. So you can tell that a top end right here is traveling up, and then the negative, it's going down on the left side. So again, how do I know that? This is my leading coefficient right here. It's 5, and it's positive. So I know that either way, the function will end with a top positive, and then in some ways it will have a different end. So 2 ends going in the opposite direction. So having said that, when I'm on the right side, according to my function right here on the right side right here, okay, I can tell that my function on the right side is going to be traveling up. Okay, so when this x is approaching positive infinity, my function, which is f of x or s of x actually in this method right here, if I want to be completely correct, s of x, because it's the name of the function, it's traveling up as well. And since this is an odd function, on the negative side, my function should be traveling down toward negative infinity. But let's just check it. On the negative side, my function, in fact, travels down. Now, if you need to write it down, positivity. All right, guys, now question 23. Again, this is t of x. I know that this function is set in a standard form from the highest degree to a descending to the smallest. I also know that this is an even function with the degree 8. So that means both ends are going to travel in the same direction. Now, I also know that my leading coefficient is negative. All right, so negative leading coefficient means that my end of the function, at some point, it will end up going down. Now, it is an even function, so whichever way it will go, I don't solve it, so I don't know what it'll look like, but both ends will end up going in the same direction. So even without graphing it, I can tell that on the positive and the negative side, okay, so on the positive and the negative side of the graph where the x is traveling toward positive and the negative side, I know that both of these ends are going to continue going down. So I know that my f of x, or in this case, t of x, okay, will be going toward negative infinity. Because again, t of x on both ends is traveling down, okay? Now, I am going to check it on Desmos right here. And in fact, both of the ends are going down on a positive and negative side of my axis, okay? All right, and then the last one right here, again, I would graph it. So let me look at Desmos. All right, so this function right here, I put it into Desmos right here. So this is your function typed exactly the way you want it. Again, you can zoom it out a little bit. So you see how the ends are going up right here, okay, and how the ends are going down this way. Now, even without graphing, but again, I want you guys to graph it to confirm what you say, but even without graphing, what do I know about this function? I know it's set in a standard form. It's starting with the highest of a 5th degree, and then it ends with no x, right? So what I do know is that this is a 5th degree polynomial, which means I should have 5 zeros. Okay, that's what it tells me, that I should have 5 zeros, okay? All right, now when it comes to the end behavior of the polynomial, this is an odd function. So again, odd function with a negative leading coefficient. So my coefficient is going to start somewhere here, and I should have 5 zeros. 1, 2, 3, 4, 5. And again, this is not necessarily said that's how it would look like. I don't know the zeros itself. I don't know where would they cross and how many multiplicities would they have. But the main key is, if you're sketching something, that this is an odd function, means that 2 ends go in the opposite direction. The negative leading coefficient right there tells you that the function will end going down at the end. So I know that far, so I can tell that on the positive side of my x's, so when my x's are approaching positive side, my function is traveling down, okay? So my f of x is traveling down. I also know that on the positive side of my negative side of my x's, so when x's are traveling toward negative side right here, so going this way, my function is traveling up because it's the opposite, right? So just make sure that you understand that whichever end, because it's an odd function, when it goes down, the other one has to go up. When one goes up, the other one has to go down. All right, question 25. So for this one, it says, which cubic function has the zeros at 9, at 0, and -5? Well, again, you can graph each of them and figure that out to make sure you confirm your answer. But to solving it algebraically, I will take these zeros right here. So x equals 9, x equals 0, and x equals -5. And I will set them equal to 0, which means I would subtract the 9 to the other side. So x minus 9 now equals 0. I would subtract the 0 to the other side. So it'll be x minus 0 equals 0, which is really just x equals 0, right? So it goes back to the same. So it's just x, basically. Okay. And then I would also set this equal to 0 by adding the 5 to both sides. So x will equal, x plus 5 will equal 0. Okay. So that's a factor form, all right? So comparing to my answers, okay, what do I have? All right, I got none of these, +9 and +9. It has to be either A or C because x minus 9 is in there. But now, is it x squared or is it x? Well, if I have a x squared minus 9 equals 0, if I move the 9 to the other side, x squared will equal 9. And then if I square root the x squared, I get x equals plus or minus 3. So it cannot be a square. It has to be answer C. Okay, so again, the +5 matches right here. So +5 will match your factor right here. X minus 9 will match your factor right here. All right, cubic function that has zeros at 4 and multiplicity of 2 with multiplicity of 2 and x equals -1. So again, if I want to take factor of 4 and equal it to 0, I'm going to subtract the 4 to go backwards. X minus 4 will equal 0. And then we also have x equals -1. So I would add the 1 to both sides. So x plus 1 will equal 0. Now these are my two factors, okay? So I got x minus 4 and I got x plus 1. Now it also states that it's a multiplicity of 2 with the x equals 4. That means that 2 will go up here. So looking at my answers, it is B. No? Nope. Let me take that back. For 26, no, for 26, it will be answer A. Sorry about that. Why is it not B? It's because you got -2x. If you equal that to 0, x will equal 0, okay? And you don't have another 0. You only have 4 and 1, -1. So this could not be. So it has to A. I just missed it, didn't see it, that it was set up backwards, okay? All right. Question 27. Which statement about the graph of the function g is true? Well, degree. First, is it even or is it odd? Okay, so let's make that elimination first. So it is even because both ends go in the same direction. So it's not C and it's not D. Okay, now, other than that, we already know it's an even degree. Now, a leading coefficient is positive and negative. Well, we're going to look. It is going down, so it is negative, okay? The and tail is going down. So the correct answer for this question is B. All right. Question 28. It says determine The degree of the leading coefficient. How do we know the degree of the leading coefficient? Well, we're going to count the multiplicity, okay? Multiplicity equals the degree of our function. So I have a bounce here. So let me remind you, a slice, it's a multiplicity of 1, okay? A bounce, it's a multiplicity of 2. And then a slide, so a bounce will be like this, and then a slide, it's a multiplicity of 3. Okay, that's a slide. So again, do I have here? I have a bounce, so that's a 2, and I have a slide, so that's a 1. So this function degree is 3. Okay, now here I have a slice at 29. I have a bounce, and I have a slice. So again, for 29, this is a 2, this is a 1, this is a 1. It would be a degree 4. Okay, that's it. All right, next question. Okay, question 30. Which of the following could be represented by the graph? Again, you need to figure it out. Is that an even or odd function first? So again, because these two ends go in the same direction, it is going to be an even function. So it cannot be, and let's check, make sure they all are set in a standard form from the highest to the lowest they are. So it cannot be b because that's an odd function, okay? It could be A, C, and D. Now, the next thing I'm going to look at is what is my leading coefficient, positive or negative? It is positive. So it could not be A because there is a leading coefficient that's negative. And it could not be C either because that's a negative leading coefficient. So the answer to this question, the correct answer to this question is D. It is a 4th degree. Even though it bounces once, remember, it could be more than 2 in an even number. Okay. All right. Here, 31. All right. A sketch a polynomial. So Isaac sketch a polynomial, g of x, with a total of 3 real zeros, okay? And the end behavior describes as when x approaches positive infinity, g of x approaches negative infinity. Which of the following graphs could represent Isaac's sketch of g of x? So again, what do we have here? Key information. So for the key informations right here, we have that we got 3 zeros, okay? And behavior describes as when x approaches positive infinity, so when x's are going toward positive, g of x, which is my function, approaches negative infinity, means my function, it's going toward negative infinity. So on the positive side, my function is going down. So it cannot be D or C because both of those ends go up, right? So it has to be either A or B. Now, it's talking about 3 real zeros. So the correct answer for this question will be A. How do I know that? Because 1 slice, 2 slice, 3 slices. So that's 3 zeros. Here I got 2, which is a bounce, 3, which is a slide, 4, which is a slide. So this is 4 zeros. So the correct answer would be A. Zeros means x-intercepts, okay? All right. For question 32, which graph could represent the function? Well, I have a negative x cubed minus x squared plus 5x, okay? So first thing I want to see, I have a negative leading coefficient. So this is positive, that's a no. This is positive, that's a no. It could be either A or D, okay? Now, for this cube function, with the negative leading coefficient, there is a slice here, which is 1. And there is a bounce here, which is 2. So that makes it a 3, but it could be more than 2 here, right? So we don't know that. But here we got a 1, we got a 1, and we got a 1. So that's definitely a cubed function. That's definitely a 3rd degree function. So it's A. All right, now we're going to do a regression. What I want you guys to concentrate on is simply a quadratic regression, okay? So, sorry about that. So I'm going to plug it in into Desmos. All right, so we're going to cancel that. We're going to get our table. We're going to plug in those numbers. So I got 1, 6, 11, 15. All right, I just skipped it, pause the video, and put it all in for you so it's a little bit faster. Now remember that my equation is y1, squiggly on the left top corner. You get ax squared 1, because we're referring again to my table. I'm letting the function know which table it is. Okay, plus bx1 plus c. Okay, so these are my results. That's my A, that's my B, that's my C. Okay, so now when it's asking you for let me see. I'm sorry, y'all. It is asking you to determine the regression equation for the data. So that's for part A. I don't have that little slide here. Actually, let me get it. Sorry about that. So I'm just going to write it out. So if I would have filled in and, rounded up to 1,000, my equation would be 0.124 x squared. How do I got that number? Well, this is your A, right? I just round the 8 to the 4th up. Okay. For your B, you had negative 3.859 x. Okay. And lastly, plus C, which is 58.404. So that is my regression equation. Now, if I would have predicted the number of customers on the day 4, round to the nearest volume, I would plug in 4 instead of the x. So I would have 0.124, 4 squared minus 3.859 times 4 plus 58.404. My final answer would be 45. Okay? Now the same thing we're going to do here. We're going to put those numbers into the Desmos equation. So I'm going to delete this table right here. Okay, and make a new one. So again, we're going to start with a 10. That's your times. 20 seconds, 30 seconds, 40, 50. I'm going to pause the video and fill in the table. So again, I put this equation in for the quadratic regression. These are your A values, these are your B values, these are your C values. So now going back to my function right here, if I want to write out, determine the regression equation data, I'm going to plug in for A, which again is 0. If I put it, so for A, I put 0.132 x squared. For B, we had 15.925 x, and for C was 86.57. So again, I got these numbers from using these right here as your A, B, and C. Now, the second part of the question talks about use the regression equation to predict the shuttle speed after 100 seconds. Of course, the 100 seconds will be plugged in instead of the x. So 0.132 over 100 squared plus 15.925 times 100. So again, you're plugging in instead of the x, and then plus 86.57. And all of this is approximately 2,999.07 feet per second. Okay? All right, now the last question right here, it says using zeros and their multiplicity and the end behavior sketch a graph. Well, first of all, you're going to equal all these things to 0. So negative 2x equals 0. I got x plus 3 equals 0. And x times minus 5 equals 0. If we equal it to 0, okay, x will equal 0, x will equal negative 3, and x will equal 5. These are my zeros, my x-intercepts. So at 5, at negative 3, and at 0, okay? These are my 3 zeros, okay? Now, what else do I know? I also know that my leading coefficient is negative, okay? So that means my function is going to start from the bottom, okay? What else do I know? I also know that my multiplicity is a 2 in here and a 1 in here. So at 3, it's a bounce. And at 5, it's a slice. So coming from the bottom, if I'm going to go and do it, coming from a negative leading coefficient, I'm going to slice through the 5. Okay, I'm slicing through a 0, and I am bouncing at 3. Okay, so, and this is also an even function. How do I know that? Because again, you got 1, 2, 3, 4. So this is a 4th degree polynomial. So even means both ends will go in the same direction. Okay. All right, and then the last one right here, your question 36. Let's see. What do I know about it? Well, I know I have a positive leading coefficient. That means it's going to be coming from the top. Let's see how many zeros or multiplicity I have or degree. I got 1, 2, and 2. That makes it a 5. So this is a 5th degree. Okay. I also know that my zeros are going to be, if I equal it to 0, negative 1, positive 4, and negative 4. Okay. So positive 4, negative 4, and negative 1, which is somewhere here. Okay. Oops. Wrong. I'm sorry. Negative 1 is right here, guys. Sorry about that. Negative 1. All right. I also know that at 4 and negative 4, I'm going to have a bounce. And at negative 1, I'm going to have a slice. Okay. So if I continue going, I'm going to bounce right here. I'm going to slice through negative 1, and I'm going to bounce right here. Okay. I also know this is a 5th degree, which is odd, which means my two ends are going to be on the opposite direction. And again, you can graph this to make sure that it's looking similar to what you're describing and then be able to read it, right? So again, positive leading coefficient starts on the top here, goes down, you have a bounce right here, that's a 2, you have a slice, that's a 1, and you have a 2 right here. So it should look something like this. All right, that concludes this review. Please make sure you go over the test corrections or the retest and what mistakes you made to correct it as well, and use Desmos or practice Desmos as well to graph anything and everything you possibly can to check your answers.